Let's figure out the total volume of an ice cream cone, including the cone and the ball of ice cream on top. Specifically, let's find the volume of the ice cream cone bounded by these two functions. The first problem is to figure out, is this really an ice cream cone? The graph of z equals the square root of x squared plus y squared is a cone, and in fact, the angle between the y-axis and the cone is pi divided by 4, 45 degrees. That will be important later. Now, what the heck is x squared plus y squared plus z squared equals z? It might help to recognize that if we bring the z to the other side and it's complete the square to x squared plus y squared plus z minus a half squared equals a fourth, which is the equation of a sphere centered at 0, 0, 1 half with radius a half. So yes, in fact, the region bounded by the cone and that half sphere does look like an ice cream cone. And we're going to use the spherical coordinates to integrate this volume because there is a radial symmetry about the origin that is going to help us when we set it up as a spherical coordinates integral. The integral is just going to be easier than if we try to set it up as a Cartesian coordinates integral. By the way, if you use the usual change of coordinates to a spherical, the equation of this sphere becomes rho squared is equal to rho cosine phi. So rho is equal to cosine phi is going to give us the upper bound for rho. Therefore, this ice cream cone in spherical coordinates is given by rho between 0 and cosine of phi, for phi between 0 and pi over 4, and for theta between 0 and 2 pi. And so I can set up the integral for the volume in spherical coordinates as the integral from 0 to 2 pi in theta, 0 to pi over 4 in phi, 0 to cosine of phi in rho, and then I'm integrating the function 1 times the conversion factor to spherical coordinates, which is rho squared times sine of phi. The first innermost integral is with respect to rho. The integral of rho squared is rho cubed divided by 3, evaluate at cosine of phi, and I get this trigonometric integral, which I can solve using u substitution. U equals cosine of phi, and I get cosine to the fourth of phi divided by 12. When you evaluate that between pi over 4 and 0, you get 1 over 16, and when you integrate from 0 to 2 pi, 1 over 16, you get pi over 8. So that is the volume of our ice cream cone.